So in this screencast, we are going to look at naming ions and then putting those together to name binary ionic compounds. Okay, what we're going to hopefully accomplish by the end is to correctly name metal and nonmetal ions, correctly name a binary ionic compound consisting of main group elements. Main group elements just mean not those transition metals that are kind of in the middle of the periodic table. Then, hopefully, we're going to be able to determine the correct chemical formula for a simple binary ionic compound. Okay, so naming metal and nonmetal ions. Metal ions are pretty straightforward. You just simply name the name of the metal. So for instance, you should know that this is sodium chloride. This element is a metal and it is sodium. So that first half, that metal ion, is just called sodium. Nonmetal ions, we take the root of the element name, and sometimes this is difficult, so we'll go through a couple of examples, plus the ending "ide." So chloride, or I should say, chlorine, is the name of the element Cl. The root of chlorine is chlor, so if I have the Cl minus ion, the name of that ion is the chloride ion. The name of this, jump back up here for a second, Na plus is called, oh, I spelled that wrong, sodium ion. Okay, so if we're given the formula, how do we determine the name? Again, identify the metal ion, and that's always first, and then we just use the element name for that. Identify the non-metal ion, which is always second in a simple binary. Find the root and add IDE. So here's one we haven't looked up or haven't seen. Al2O3. Identify this as the metallic ion. Its name is aluminum. O is the oxygen element. It is a non-metal, so I'm going to use the root for oxygen. It is ox, and then add the ending ide, so aluminum oxide. Okay. So, given the formula, how do you determine the name? Again, name the cation, which is the metal, same name as the element. Name the anion, that's the non-metal part. Change the ending of the element to IDE. It is the root. Subscripts don't matter. I want to just give you kind of examples of these, okay? So if you have the sulfide ion, sulfur minus 2, that is sulfide. Phosphorus forms a minus 3, and you should be able to also predict these charges by the location of these elements on the periodic table. This is the phosphide ion. I guess I should add ion. Another one that sometimes kids have trouble with is iodide with a minus 1, and it is the iodide ion. Okay. Nitrogen would form a minus 3. That is nitride. I think those are, oh, and the other one is Se. Trying to think where that is on the periodic table. Do you believe it's a minus 2? Right, and its name is the selenide. Okay. Double check that I'm correct on that with where that is on the periodic table. All right, any questions, please ask. So, binary ionic compounds. Binary means 2, so a binary ionic compound contains 2 elements. One type of metal, one type of nonmetal, just 2 elements. What happens if I need to determine the formula for a binary ionic compound? Let's let's look at the two examples that we had before, just for a minute. We had sodium chloride, and we also had aluminum oxide. How come sodium chloride doesn't have any subscripts, but aluminum oxide does? Well, let's look at the charges. Sodium forms a +1 ion. Chloride forms a -1, so that's +1 plus a -1. That equals a 0. Oh. Looking here, aluminum, you should remember or be able to find that aluminum forms a +3 ion. I have 2 of those ions. That's what this subscript means, correct? I have 2 of this element. Okay. Then I have the oxide ion, -2. Again, you should be able to tell that from the periodic table. I have 3 of those. O -2, O, I should say 2 minus. What is the total plus charges here? +6. So that means, and remember what that means. It means each aluminum has lost 3 electrons. So collectively, they've lost 6 electrons. I have 3 oxide ions, total -6 charge. That means each of these oxide ions has gained 2 electrons. Where did those and so there's 3 of them, so there's a total of 6 electrons. Where did those 6 electrons come from? They came from these aluminum ions. So the total number of electrons gained has to equal the total of the number of electrons lost from the metal ion. Overall, this compound is neutral, meaning the number of electrons lost from that metal have to equal the number of electrons gained by the nonmetal. But overall, ionic compounds are neutral, right? So how do we use that to determine the formula of a binary ionic compound? When we write ionic formulas, metal always comes first, the nonmetal anion always comes second. Determine the charge of the metal ion from using the periodic table, or the 2 that you have to memorize. Remember, zinc, you have to memorize, is always a +2. Silver is always a +1. So determine the charge of the metal ion from the periodic table. Then determine the charge of the nonmetal ion, also from the periodic table. Adjust the subscripts so that when you add up all the charges, they add up to 0. What does that look like when we go to apply it? Here I have magnesium oxide. Magnesium, that's the name, that's the symbol for the element. It's in group 2. It's going to form a +2 ion. The anion is the oxide ion. That's a -2. Hopefully you can see this magnesium gives up 2 electrons or loses 2 electrons. This oxide, or the oxygen atom, is going to gain those 2 to become the oxide ion. The formula would be MgO. Magnesium chloride. Again, magnesium, group 2. It's going to lose 2 electrons to become stable, forming the Mg+2. Chloride ion, group 17, or 7 or 17, has 7 valence electrons. It's going to gain 1. So this is going to lose 2 electrons. A chlorine atom is only able to accept 1, so I'm going to need 2 of these to accept both of those. The formula should be MgCl2. Magnesium forms a +2 ion. Nitrogen, the nitride ion, has a -3 charge. This will end up being Mg3N2. The idea being each magnesium is going to lose 2 electrons. Each nitride is going to gain 3. I need this for a total of 6 electrons lost, 2 nitrogens, or 2 nitride ions for a total of 6 electrons gained. So pause the screencast, make sure that you come up with these names, and I'll fill them in for you. So LiF, lithium fluoride, by the way, it does not need to be capitalized. Barium chloride, aluminum bromide, calcium oxide, potassium nitride, aluminum phosphide. You should also know why I have subscripts in certain places. So just to recap and to add maybe a new term, ionic compound is a neutral compound held together by ionic bonds. Ionic bonds are the electrostatic attractive force between cations, made from metals, and anions, typically from nonmetals. We're going to introduce a term formula unit. This is the lowest whole number ratio of cations and anions in an ionic compound. Okay, so it represents the smallest whole number ratio so that I get a neutral compound. It really does mean that it's like the smallest unit of that crystalline structure that identifies the ionic compound formula. And that ends our screencast.